Prakash, working as assistant professor in the Department of Mechanical Engineering, SNS College of Technology. Today we are here with our friends to discuss a DT-based case study on need for multi-stage air compressors. So before going to the topic, let's have a small introduction about yourself.
So hi, myself Hari Vishnu, a second year mechanical engineering students, and my friends are Hari Kishan, Mohan, Dharanish and Dharanidharan. So we are going to see this case study on 5 stages of design thinking. The 5 stages are empathy, define, ideate, prototype and test. And the machine will be taught by Mohan.
Now we have told that we are going to discuss with an DT-based case study. Okay. Now let us start with Mohan. Okay.
As we can see, this is one additional application for robotic arm in thermal applications. And in this one, we have robotic arm which can control the raw material in 368 degrees, and we are using servo motor and grippers, and this is conveyor which passes the raw material, and the whole system is taken place by a pneumatic air control.
Okay, what you're telling is, so this is a robotic arm. Here the working component we are using is pneumatic based working. Okay, so the pick and place and the conveyor, everything is made by pneumatic. Okay. So as our case study told, okay, now let's continue.
So speaking of pneumatic, the component which is going to relieve the pneumatic pressure is the air compressor. One of the main issues of air compressors is the single stages air compressor. So let us take for example, we need high pressure. So that high pressure suddenly we cannot produce in a single stage air compressor.
Okay, so going with a single stage air compressor. Okay, can you show, here we are using an air compressor. Can you show how the working takes place here? So this is a single stage air compressor. Okay.
So in this single stage air compressor, we have one in motor and one cylinder. So this one cylinder can give up to a certain amount of pressure. Suddenly, for example, let us take it is giving up to 200 pascal pressure. Suddenly we need 350. We cannot suddenly push to 350. P1 to P2 we cannot suddenly push. So what are we going to do is, we are going to put 2 cylinders.
So you are going with the empathy part. So what is the empathy you are telling is that here
A single cylinder can only
produce the required pressure. So if you are going with an
efficiency we are using.
you are telling that when it is in a single stage only the required pressure is very less, limited. If you want to go with a high pressure, it cannot be obtained this. What is the other empathy you are told?
We are going to implement 2 cylinders.
That is your idea. What is the empathy behind this? What are the existing problems here?
We can't suddenly push pressure.
We can't suddenly increase the required pressure. If the pressure is very high, you cannot make it. And then what is the other empathy you are telling is the design.
Yes,
What is the design parameters here?
It is a small, and if we want to use a bigger one, we want a big size.
Or if you want to go with the required pressure, then you have to increase the diameter and the stroke length and all. So dimension has to be changed.
Yes.
So these are the empathy part you are. So now what is your idea behind this?
Ideate is we can increase the diameter, or we can
Increase
increase
the
the
number of
number of cylinder in the air compressor.
Oh, you are going to increase the number of cylinders. So what is that called as? That is called as stages. What is that? Multi-stage. Okay, what is the difference between multi-stage and?
So in single stage we usually use a single cylinder which we can't produce a high number of pressure. So we are using the multi-cylinders where we can use more number of pressure to do an output.
You are going with
A single stage 1 plus 0 to 350, that is it, sir. It takes so much of time. When we go for multi-stage, we can split it into 2 parts, 0 to 225 and 225 to 350. It takes less time than the 0 to 350, sir.
Okay, what is the purpose of going with the 2 stages
Sir,
rather than going with a single stage?
sir, increased efficiency, sir. Thermal efficiency is considerably increased in multi-stage.
Time consumption.
Time consumption also reduces.
Your time consumption and what about the heat formed and?
Sir, in single stage, so much of heat is lost, sir.
More work done, sir. It will lead the more work done, sir. If we are using double cylinder, it will give more work done in the small number of heat produced.
You are telling that in a single stage more amount of heat is produced when the compression takes place at our stretch.
Yes, sir.
So that what you are doing is
We are using double cylinder for second stage for
okay. So now we are going for the multi-stage air compression. So now let us conclude with the benefits of the multi-stage air compression.
Sir, when we use the single, let me add the benefits and disadvantage. When we use a single multi compressor, our time consumption is more or less, and the heat produced is also less.
You are using an intercooler in the multi-stage so that heat produced is taken away.
So which overall increases the thermal efficiency of the system, sir.
Now we are telling that when the heat is created, work done is reduced. So for the less work done, the same amount of air is compressed. Okay. Thank you.